here we go. If you can remember the 4-letter acronym that I gave you, as far as the 4 different ways we will both learn and show that we've learned calculus, was vague. V for verbal, A for analytic, which is algebraic, N for numerical, and G for graphical. The most important one, the most predominant one that's commonly used and most people have difficulties with was what? Analytic, the algebraic. So analytic, the algebraic, we're going to do a lot of that today, i.e. no calculator. And then we're going to do some with a little bit of graphs, but mostly it's with algebraic manipulation. Today's lesson will revolve around PreCalculus's unit circle review, solving trigonometric functions, identities, and whatnot. And of course, what we've been doing recently with finding zeros, vertical asymptotes, and all that good stuff. So here we go. The very first thing that I have is an inequality. Looking at this inequality, what would you do first, Caitlin?
Add 2 to 0.
Add 2 to 0. No, I would have moved the 2 to 0 only because of the fact that it's quadratic. When it's quadratic, I want my x squared, my x's, and my numbers on one side set equal to 0. Okay? So real quick, what I'm going to do is I'm going to change this slightly only so that I can identify what the zeros are. I understand this is an inequality, but the main thing that I need to find out is where things are equal to 0. Okay? So here we go. Factoring this out, we'll factor to 2 binomial factors. Teddy, do you know those 2 binomial factors that I would write? Anyone? What 2 binomial factors would this factor out to? Yes. Go ahead and don't raise your hand, just spill it out.
3x minus 2.
Yep, 3x minus 2 and 5x plus 1. They do FOIL out and you get the following quadratic. From there, I know one of my zeros is what? Anyone? For this, negative 1/5 and also a positive 2/3. If you can't see it that fast, set it equal to 0 and solve for x. But get faster because you're going to have to get it that fast. Now comes the number line representation. Here comes the negative 1/5 that I looked for. Here comes the 2/3. Notice I did not put 0. I know where 0 is at. I don't have to write it. The reason why I didn't write it is because this inequality sign says these are going to be open at those existing wanting to be 0 points. So that I'm only going to evaluate how many intervals for the signs. 3. Yes. So I have 3 intervals. Here, here, and here as far as when I'm going to evaluate. Livia, give me a number in the first interval. We're going to say let x equal what?
Negative 1.
Negative 1 is perfect. So if I put negative 1, I want to put it back into the factored. When I do sign tests, I want to put these lets into the factored form because it's easier to extrapolate the sign of it after the multiplication has occurred. Jake, putting in negative 1 into my factored form, what is the sign of this first binomial? Negative. Yes. What is the sign of the second one, Jake? Negative. So whenever I multiply those two, anyone, what do I get? Positive. I have a positive value. Positive values within that interval. We are solving inequalities. Now comes the next one. Let's say Peyton. Let x equals what in this? 0 is a perfect number. Use it as often as you can. 0s and 1s. So if I put 0 in, what are the signs that I get for the first one? Positive, negative. So my multiplicative sign becomes negative. They will not always alternate like this. Some can be positive, 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 negative. Just be cognizant. Don't try to establish patterns. Just do the math. Jacob, third interval, what would you let x equal? Perfect. Let x is equal to 1. Anyone, what's the resulting sign after the multiplication? Positive. So I have positive, positive, non-inclusive of course, and negative as well. Check this out. Stuff that we should remember. If x goes to infinity, what does f of x go to? If I looked at this, infinity, because 15 is positive. Because this is an even number, As I approach negative infinity, what is f of x going to approach? Infinity as well. It's going to be even. Because this is an even number, it's going to mirror what that one does. What degree is this polynomial? 2. So I should have how many zeros? 2, which I do. 2 possible zeros. You see what I'm doing? Just review. How many changes of direction because it's to the second degree? 1. Up to 1. Okay? If it was like x to the 9th, you could have up to 8. You could have 7 changes of direction, 8 changes of direction, 3 changes of direction. Okay? And there's that piece. So the positive, negative, positive, this is probably what the graph is going to look like. Now this is what's just extra, just to help you review, because there's a lot to review. I'm trying to fill you out as far as what you actually know. The answer was only looking when it was greater than 0. Otherwise, when it was positive. So there's 2 intervals. Travis, what are they? When are you bigger? Perfect. X is less than negative 1/5. And x is greater than 2/3. There's your answer. And if you wanted to draw it out, you could. Shade it there, non-inclusive.
What if you wrote like negative infinity to?
Well, you usually only write that interval notation to describe domain, but he's saying, what if you wrote negative infinity? If you wrote negative infinity to negative 1/5, non-inclusive. But you only do that to establish domain, range, or intervals of increasing, decreasing. This, because it's an inequality, I would say please keep it as an inequality. Okay? Any questions before I move on? That was a lot. That was a lot to review. All right, so here we go. Now we go to B. Allison, what would be the first step? Perfect. So x cubed plus x squared minus 12x. Notice how I did that equal to 0 again. I know I'm going to evaluate the inequality later, and now we factor. I would suggest the very first thing is to GCF. Try to GCF it out first, so that you have that, and then you can factor this out to 2 binomials. Okay, that should be your first go-to, is that GCF. And then anyone, what do these 2 become? Yep, x plus 4, x minus 3. All right, so good factoring in this class. All right, so looking at this, I have 3 zeros. Anyone, what are they?
0,
Yep.
4, 3.
Perfect. 0, negative 4, and 3. Going straight now to my number line. I have negative 4. This time I do have 0, and I have 3. The difference between this one and the first one is that these zeros are going to be colored in. They are going to be closed. Megan, can you tell me why? Perfect, because of the equal piece. Yep. Okay. Now looking at this, Kelsey, what would your first let be? Okay, so she's saying let x equal negative 5. And anyone, where do I put this negative 5 again? The factored form. Primarily this one. So that anyone, what is my sign whenever I multiply all that out? Try it again. Negative. Okay? So we have negative 5. Negative 5 plus 4 is negative. Negative 5 minus 3 is negative. So these 2 multiplied to positive. Positive times a negative is a negative. Okay? And yes, you'll do this a lot throughout the year. Just try to get efficient with it. All right, so what's our next let? Melanie, what would you say your next one would be? Perfect. I do zeros and I do ones too. Okay, so doing negative 1. Anyone, what's the sign of all that multiplication? Try again. Positive. Again, you're putting this negative 1 right here, here, and here, and seeing what those multiply out to. And let's Pick another one between 0 and 3. 1. Anyone, what's the sign? Negative. Okay? And then the last one, I would probably let x equal 2.5. Okay, 3.5. Yeah, you can. I'm going to go with 4. Yes, and you get a positive. We want it when it's less than or equal to 0. So our answers are going to be boom and boom. To write it out, let's go ahead and account for the first one on the left. Let's go with Bryson. What would that show?
X is less than or equal to -4.
Perfect. And then the other one?
0 is less than or equal to x, which is less than or equal to 3.
Nice. There's your answer. You still good?
Yeah.
All right. Let's do the next one. What is the word that's associated with these two things and it starts with an M? Should we factor this? No, because it's already factored, right? These are already factored with the multiplicity. So with the multiplicity of 2 and 3. Remember, even numbers are where the graph will go and touch and bounce off of that x-intercept. Odd is where they go through. Okay, so if it's even, it bounces off, reflects, and the odd go through. So looking at this, the only two zeros that I need to get from this are what? -3/2, 4. Again, I'm setting it equal to 0 only to solve. Open or close at these points? Open, because of that guy. So we have -3/2 open, and we have 4 open. Chances are for your first assignment of let x equals, Alexis, what would you use for that first interval? Perfect. Let x is equal to -2, so that when I plug it in, this will always be what sign? Positive y? Squared. We do actually have to plug this in and evaluate this other one. What is this one going to be? Positive, because 4 minus a -2 is actually 16. So 216 positive, yes, it would be that. So looking at that, let's go with positive. Your next x is equal to would probably be 0, right? Yeah, would that be safe to say? What would your sign be? Positive. Don't think that they're going to alternate. So there's positive and positive. And the last one, we could say x is equal to 5. And what's the sign? Negative. Because 4 minus 5 is a -1. -1 cubed is a negative. Plugging it in, multiplying it out will give me a negative. We good? Alright, so now I need it less than 0. And the only time that happens is in this interval. So my answer in inequality, Ryan, is what? Perfect. X is greater than 4. You guys are killing it. You're doing well. Questions? Alright, so let's keep going. We will do D, then E. Melanie, start us off with D, please. Okay, so factor the top. Factors to what? Yep, x minus 5, x minus 4. Anyone, how about the bottom? Yes, the bottom is a difference of what? Squares. So plus 3 minus 3 greater than or equal to 0. I know I'm going to evaluate that. I'm just going to use the equals. What's different about this though? Rational. So we're not just going to examine the x-intercepts. Because it's rational, the x-intercepts occur when I set what equal to 0. The numerator, the top. I'm also going to find more points so I can see how many intervals of analysis I'm going to use. Where do those other 2 points come from? Asymptotes. Only one kind of asymptote though. What is it? The vertical. The vertical. Okay? Yes, the removal as well, they come into play, but basically if they're on the vertical, if they're on the denominator, This one is numerator and denominator. Alright, so let's figure out the top. X is equal to what? 5 and 4. And the bottom? Negative 3 and 3. These are killing it. So looking at this, if I were to create this, how many intervals of interest am I looking at? No, there are 4 zeros, so it's 5. Remember, there's 2 zeros, there's 3 intervals. One more than however many zeros. Okay? Just something to simultaneously think about as you're doing your problem. Because speed, you're going to see, is what's going to get a lot of you on this first test. Just because you're not used to being timed and pushed to that, maybe not as much. Alright, so first let x is equal to, possibly might be, Sheen, or anyone, would be what? Negative 4. So if I tried negative 4, and I put it here, here we go. What's the sign for this little piece right here? Negative. Here. Negative. And then negative. And then negative. So all of that multiplied out is positive. Cool. Close or open on these points?
Open. Close.
Who said both? I thought I heard, so someone said close, not both. It's actually both.
Asymptotes.
Asymptotes are open, zeros close. Big, big, right there. Why are the asymptotes open? Because you can't divide by 0. They're asymptotes. Okay? You can't divide by 0. So looking at this, let's do a next one. What are next let x equal? 0. Plug that in. Anyone, what's my sign? Some of us are faster than others. It is negative. Between 3 and 4, you would use Ethan's favorite number, 3.5. Yes, 3.5 would give us a sign of positive. Between 4 and 5, another favorite number of his is 4.5. He likes those 0.5s. That would be negative. And then possibly his favorite number past 5 is 6. Shut up. Alright, so will be a positive. So that looking at this, we have 3 answers here, here, and here. So let's account for all of these answers. And anyone, the very first interval, actually I'll call on you. Let's go with Taylor in the back. How do I show that first one? Yes? Are you still working? Let's go with Travis.
X is less than negative 2.
Perfect.
3 is less than x less than or equal to 4.
Perfect.
And then x is greater than or equal to 5.
Like a champ. There you go. Let me pause it. Someone's at the door. Alright, we get back. Good job. That's the answer. Nicely done. Let's move on. Or unless there are any questions. You got the gist of it? It's not bad, right? The algebraic manipulation. T. Let's go with E. I split them into 2 groups perfectly. Perfect. So when I factor by grouping, we're doing this. The GCF of that first one, anyone, is what? X squared. Because when you factor that out, you get x plus 3 left over. And anyone, what's the GCF of the other piece? Minus 4. And if you don't know, try to match this with whatever's here. Because if it matches, which it will, it should, that's your group. That's one of them. What's inside is 1. What's outside is the other. Again, I'm setting it equal to 0 just so I can find the points of interest, the x-intercepts. Bradley, what are they?
X minus 2, x equals 2, and x minus 3.
Perfect. Negative 2 and positive 2. And a negative 3. Which of these 3 do you think most people would forget? The negative 2. Because they see x squared is equal to 4 and they just say 2. They forget because it's squared, it's also the negative. So please count for those. Try to get the brain back to training for that. And the big thing that you should see is has 3 answers because it's a third degree polynomial. Okay, 2 change of direction, 3 answers. That should help you out. Now, let's go ahead and go to the number line. We have -3, we have -2, and we have +2. Andrew, what would be the first number that you probably try to plug in? -4, perfect. You plug in -4 into this piece. What are you going to get as a sign? Negative. Oh, good. These are open or closed? Open. Andrew, try again. Go between -3 and -2. What would you use? -2.5. What's your sign? Positive. Because you have a negative, negative, positive for a positive, positive when it multiplies out. This negative that I'm showing you here is because I've factored this out even more. Okay? So negative, negative, positive coming out to the positive. Alright. What probably is the number we try next? 0. And we would get a negative. And then trying like 3, you'd get a positive. What do I want? Greater than 0. So I want here, and I want here. When you see greater than 0, you should be thinking positive. You should read that as values that are positive. Okay? Especially when you're trying to interpret it in the context of what it gives you. Any questions? So my final answer, Destiny, is written how?
X is less than negative 3 is less than x.
Okay.
Is less than -2. And then x is greater than 2.
Perfect. We're good? Alright, there are bonus points today. There's a lot of them up for grabs. We will get to them here in just a bit. You definitely don't want to forget what you just did. Alright, piecewise function. How many functions do you see? 2. You see 2 pieces of a one piecewise function. So you'd say f of x is equal to something when something and something when something. Hannah, let's say that this is the first one we're looking at. What's the domain? Try again. Yep. X is less than or equal to 0. See it? Jake, what's the domain of the other one? Good. X is greater than 0. Anyone, is this a function? Yes, because why? There's no overlap. It passes the vertical line test. Don't change it on your paper. Is it a function now? No. Okay? Alright, so let's move. Let's go with this first function. Who knows the function already? Go for it, Olivia. -1/2 x plus 1. She knew the slope was down 1 to the right 2, so that's -1/2. She knew my b value, otherwise known as the y-intercept, was 1, so she went straight to the y equals mx plus b. Easily done. Okay? Michael, how about the other one?
X squared minus 1.
X squared minus 1. Just a little review. These are easy. Then we go to the fun stuff. There we go. This is what we were talking about. I was talking about at the beginning of class as far as refamiliarizing yourself with the unit circle. This is the only time we're going to meet until your test. I will record the last page of notes. We'll tell you when it's on. I will post that when it's on. This, I think, is a big key as far as those of you who are wanting to get the 95s and above or the hundreds. Very few hundreds on this first test happen because of this. They don't account for all possible answers. Okay, so here we go. The answers will exist between 0 and 2 pi. Okay? Inclusive on the 0, non-inclusive on the 2 pi. Already, I think you should be thinking about the unit circle. So the unit circle, let's create this real quick. Boom, boom, boom. Let's go with boom. And here we go. So, 2 different ways that you can learn the unit circle. I'll show you the hand trick. Hand trick's cool, but I don't think it's as cool as my baseball diamond trick, and I'll show you here in just a bit. On my hand, in the palm of my hand, I have square root of x over 2. On my thumb, I have cosine of x. Do not write this down on your hand for test. Stay, please. This is just for instructional purposes. So, if I show you this, now I know it's not on the video, so I'll just pause the video, there's no point. Here's the first quadrant. Here's the x-axis, here's the y-axis. 30, 45, 60, 90. 0 degrees. Do you see it? Alright. So at 30 degrees, I want you to count how many fingers? 3. Put it where the x is at. Root 3 over 2 is the cosine. 1 finger, put it here, root 1, it's just 1. So the sine is 1/2. You see it? 45, it's root 2 over root 2. You see it? Cosine is the x value. The sine is the y value. Let's go to 60 degrees now. How many fingers do I put in for cosine? 1. So the cosine at 60 is what? 1/2. The sine at 60 is what? Root 3 over 2. You see it? 90 degrees. How many fingers am I going to put in for the cosine? 0. What's 0 divided by 2? 0. Cosine at 90 is 0 because the point is 0, 1. Put in 4 fingers. Square root of 4 is 2. Over 2 is 1. There's that sign. You see it? It's a little elementary. It's all good, but it does help. Now let me show you the way I'm hoping that you'll adopt. Oh, wait, no, it's still recording. No problem. All right. So this one, now I'm drawing them in. And you know what's cool that I learned today? I'm going to show you this exactly how you should think it. So, x and y. X is cosine, y is sine. With me? Tangent is y over x. My goal with this demonstration is to get you to get these points fast. Okay? The way that I'm going to recreate this for you, just like that, is I'm going to start with x, because x comes before y and the opposite. I don't know, however you want to hear it. X I'm going to start with. So right here I'm going to create the x value simultaneously. And I'm going to do a baseball diamond. I'm going to count down. I'm going to start at x-axis, and I'm going to go up, clap, and I'm going to go down the clap. You with me? Here we go. 3 is x. 3, then 2, and then 1. So I went up first with the x values. Now I'm going to go back down with the y values. Again, 3, 2, 1. Now all of these, who can tell me what they're all over? 2. So all of these are over 2. Everything. Now I'm not going to do the bottom, the entire bottom. I'll just start it for you, and you can finish it on your own. It would be also 3, 2, 1. Going back up with the y's. 3, 2, 1. You with me? Reference angles is what I'm trying to train you with. You know reference angles. It's easy to find these answers fast. They are all over 2, and I square root what? The top. I square root the numerator. That's here. What's the square root of 1? 1, so I don't have to write that in. The square roots of 2, and the square root of 3 again. See it? I'm only going to do quadrant of 1 now. The only thing left to account for is what? Positive and negative. All students take calculus. Plus plus, negative plus, because it's a negative x value, a positive y value. It's a negative x value, negative y value, positive x value, negative. See it? What quadrants are the cosine positive? 1 and 4. Because I said cosine, I'm talking about the x values of all these points. They're positive on 1 and 4. What quadrants is tangent negative? 2 and 4, because the signs are opposite. You with me? What quadrants are the signs negative? 3 and 4. So you're going to be fine. I think you'll be fine. All right, so any questions about 3, 2, 1, 3, 2, 1, all over 2, square at the top, signs, done. Because once you do it from the reference angle, you're good. You can get it from any different quadrant as you go around. And if you know this already, it's just review for you. First step, anybody, what I do? You'll have 3 bonus questions from this, just so you know. I'm going to factor. What am I going to factor? Tangent of x. Because tangent of x is left there, and root 3 is left there. Nice. 2 possible sets of answers. I'm going to look when tangent of x is equal to 0, just like a quadratic, just like binomial factors. You're still looking at the pieces, because they're multiplicative pieces. But this one's when tangent of x is equal to what? Negative root 3. Already, what relationship are you thinking about? Y over x. Y over x. Cotangent's x over y. Tangent is y over x. So think about the unit circle that we just did. When the y divided by the x, say on this one, for instance, 1/2 divided by root 3 over 2. Notice how I did not write 1/2 divided by root 3 over 2. That looks ugly. Okay? If I do 1/2 divided by root 3 over 2, I know it's multiplying by the multiplicative inverse. This would be 1 over root 3. Rationalize the denominator. That's not what we're looking for. We're looking for root 3. Which one's the angle?
60.
60. It's not this one. It is 60. Because root 3 over 2 divided by 1/2 is the same 2 over 1. Those cancel, reduce to 1. So I get root 3. That's what I'm looking for. So this one's going to be a reference angle of 60 degrees. Because it was 0. Oh, I'm sorry.
Yeah.
My bad. Thank you. Because it's negative, what quadrants? 2 and 4. So quadrants 2 and 4. Reference angle of 60. Look what I do. 2 and 4 is here and here. This is 60. This is 60. You with me? We're in radian form. What is this angle going to be whenever we get that? 2 pi over 3. Good. Here's 60 degrees. Here's 120. Here's 180. Pi over 3, 2 pi over 3, 3 pi over 3, which reduces to pi. Okay? In case you can't remember it, try to figure it out with fractions. I'm trying to retrain you if you didn't already think of it this way. Okay? So this is 2 pi over 3. What's this one way down here? Not 7 pi over 3, but 5, wait, 4, 5. Yeah, 5 pi over 3. Because here's 4, here's 5. 6 pi over 3 reduces to 2 pi. So when you say 7 pi over 3, you've already passed 2 pi. You understand? Just to help you out with fractions, how to figure it out. So 5 pi over 3. Now, those 2 are answers, but I'm not done because I still have a couple more answers. When does the tangent of x equals 0? Now, tangent's y over x. When y is 0. Okay? Y is 0 at what points?
0.
So let's go through it because some people. Okay, so as I go through this way, it's going to be at 0, and it's going to be at pi, and also 2 pi. But because of our notes already saying don't include 2 pi, we're just going to say 0 pi. So what are my answers? These 4. If you do that for bonus points, there's 4 points right there for you today. Now, when I say these bonus points, I don't mean you're going to get 4 bonus points on your test. These points accumulate. The total, the top 2 teams per class with the highest scores will get the 5, maybe 10 bonus points on your actual test. Okay? That's what you're working for. All right. B. Let's do B. Oops. Let's go with Kirsten. What do I do? Okay, so cosecant of x is equal to 2. Perfect. Keep going, Kirsten. Oh, wow, you're fast. So 1 over sine, that's good stuff, is equal to 2, right? And then you flip them, because you multiply both sides by sine of x divided by 2. And you can just flip-flop. If you can recognize it, which you should be at this level, you just flip-flop those 2. So, sine of x is equal to 1/2. What am I asking myself, Peyton? When does the y equal? What angle does the y equal 1/2? So if I'm doing this, look, 3, 2, 1, 3, 2, 1, there's the pi over 6 for 30 degrees. So you know it's boom and boom. And also boom and boom. Okay? You see it? You have 5 pi over 6. You have 7 pi over 6. You have pi over 6. And you have what? 11 pi over 6. But the only ones that I care about are the positive 1/2. You see it? Positive y value. What quadrants? 1 and 2. So my answer, x equals pi over 6 and 5 pi over 6. Any questions? All right, just real quick. I love it too. All right. Oh, I'm recording that. Let's keep going. C. I was talking to math, okay? Yeah, love math. All right, here we go. Cosine squared and cosine of x. Treated as a quadratic. Something to remember, cosine squared is equal to 1 minus sine squared. Sine squared is equal to 1 minus cosine squared. Because cosine squared plus sine squared is equal to 1. Okay? Another one. Now I'm going to give this to you on test day, but not for you to use. If you did not do this over between now and then, you can use this to photographically cram anything that you might want to the last 15 minutes before you take the test. Is there strength in that? There really is. But not reinforcing cramming. Here we go. I'll talk about that later. Next time we meet, I'm telling you already, you have a pop quiz. Okay, first 15 minutes will be over your unit circle. Just like we did, know how to use a unit circle. Forward and backward. As far as finding the angle, and as far as finding the ratios. If you need to write that down, put it in your phone, whatever. Please put that down because you will have that the first 15 minutes. Next 15 minutes, you can breathe, relax, study last minute cramming. This will be next Tuesday. We don't have the test on Thursday because of the senior privilege. Say again? It is Tuesday. Yeah, quiz. The reason why I said you're having a quiz on just the unit circle, because that's a huge thing. That's a big thing. I need to make sure that that's right. Because you're still going to have it on the test part. But if I make it a quiz, that's a big grade still right there. You know what I mean? That puts extra emphasis for you to know it. Not just, I didn't know that one question from the test or 2 questions, I'm good. No, you need to re-familiarize yourself with the unit circle.
Is Friday 8 or 8?
Friday's 8A this week. Yes.
So we need to know the angles and the ratios?
Yes, angles and ratios. Just like we were going backward and forward, there's plenty of practice quizzes online. And I would very much so suggest that to you. Practice pop quiz on Google. Looking for trigonometric identities or unit circle conversions, stuff like that. You know what I mean? All right. That will be the first 15 minutes, and you have 15 minutes to relax, cram, do whatever last minute things, kind of settle into the test, and then it will be for an hour. Yeah?
When we take the test, if we bring in like a blank thing with like we need
Yes. That's a good suggestion then. Yeah, because the thing is that you're creating it anyway. You know what I mean? But having the blank, you save in a little bit of seconds. That's good. I'm okay with that. Because as we develop, I don't want you to use anything. You will create the blanks real quick. You know what I mean? But it'll be easy by then. Any questions? All right, here we go. C. We are going to use it like a quadratic, and it factors out to 2 cosine plus 1 cosine of x minus 5. Do you agree? Yes, because 2 times negative 5 is negative 10. The O and I on FOIL. Some teachers don't like you to say FOIL. I just like the O and I to get the middle. Okay? So you get that negative 9. So I have 2 problems. Cosine of x, Jake, is equal to?
5 and
Perfect. 5 and negative 1/2. Mike, let's go for this negative 1/2 bit. What can you tell me? What quadrants are you in, Mike? Come on. Cosine is what value, x or y? Cosine x. Sine's y. So, anyone, my x values are negative. What quadrants am I in? 2 and 3. The reference angle. I need the x value of that reference angle to be 1/2. So, if I did it like this, 3, 2, 1, there it is. There's that 1/2. Because I did the x's first. You see it? So, cosine of 60 or the cosine of pi over 3. Okay? Pi over 3 is 60. Pi is 180. Divided by 3 is 60. Alright, so looking at this, you're looking at 60-degree reference angle, 2 and 3. So you're looking here, and you're looking here. See it? Alright. So that's pi over 3 and also what? 2 pi over 3. Oh, my mistake. My mistake. I'm doing 1. Sorry. Speak up. I don't claim infallibility. I will make mistakes at times. Quadrants 2 and 3. Yes, thank you. Is not this one. This is quadrant 1. So it's 2 pi over 3 and this guy right here, which is 4 pi over 3. Yes, if you're confused, again, I am not perfect. By all means, speak up. We'll figure it out. Promise we'll figure it out. 4 pi over 3. 2 answers so far for that piece. Now we're going to go for cosine of x is equal to 5. Can't. Because the biggest cosine you can get is what?
1.
Is 1. Because cosine is x value. It's right here. 1, 0. What's the smallest one? Negative 1. Okay? And everything in between. We're just talking about this stuff here. Alright, so that's non-existent. So your only answers, boom and boom. 2 more. We're going to jump to letter E. And then we'll do G. And D, F, and H will be for bonus. You want to pay attention though, otherwise you won't be able to do some of those. Sine of 2x is 2 sine of x cosine of x. I don't expect you to know that. Any ones that I want you to memorize though, I will tell you which ones to memorize. Those are the most frequent ones that you'll see on the AP exam. And then you copy the rest. Plus cosine of x is equal to 0. Jacob, what do I do first? Factor. Yes, awesome. Thank you. And I'm only doing it because of the sake of time. Cosine of x, 2 sine of x plus 1. All you did was GCF that thing. Okay? So this first one is cosine of x is equal to 0. And this is sine of x, anyone, is equal to? Negative 1/2. Nice. Alright. When is the cosine of x equal to 0? Pi over 2 and 3 pi over 2. Remember, we're only in that first 0 to 2 pi, not inclusive with the 2 pi. We're not doing negative direction. We're doing positive. Alright. So what is the y value? Negative 1/2. So here we go. 3, 2, 1. Now the y values, 3, 2, 1. So I'm looking at all the pi over 6s. I'm looking at this one, this one, this one, and this one. Because this is negative, I only care about these two. That's it. So it's 7 pi over 6 and 11 pi over 6. Those are your answers. That would have been 4 bonus points if you got a 4. You got 3. I do believe in partial credit. I don't think you should get everything wrong just because of one minute mistake. That does help you because it also recognizes where your weaknesses are for you so that you don't make them again. Let's go to G. Done. No, I'm joking. Here we go. Cosine of x over 2 is equal to root 3 over 2. Already, you should identify this is different if you had x there. Okay? We'll get to that here in just a bit. I want to look at this like if I was thinking cosine of some angle is root 3 over 2. So 3, 2, 1. Ooh, I'm already hitting it. When the x value, because it's cosine, is root 3 over 2, it's at the pi over 6s. Are you with me? All right. But I'm not going to set them equal to just that answer, and that's it. Okay? First of all, this is a positive root 3 over 2. What quadrants?
1 and 4.
1 and 4, because the x value is positive. It's to the right of the y-axis. Okay? So you're looking at pi over 6, and you're looking at 11 pi over 6. But you don't set them equal to just x. You set them equal to x over 2, because that's what you had here. Multiply the leftovers by 2, you get your x equals. X equals anything, or anyone. What is that? Pi over 3. X equals anything. And then this other one is 11 pi over, multiply by 2. When I multiply by 2, this cancel reduces to 3. And this just goes to 1. So my answer is 11 pi over 3 and pi over 3. One of them is wrong. 11 pi over 3. That's way past 2 pi. The most you can do with one revolution of pi over 3s is how many? 6. 6 pi over 3 reduces to 2 pi. Use your circle. Okay? Compounded multiplication, if you think of it like that. The last 3 are bonus. Go.